All right, so you should have, either in your calculator or on a sheet of paper, came up with this matrix, which is a 4 by 5. So if you're typing your calculator, you would have typed in a 4 by 5, entered all these numbers, and then you would use that RREF, or that reduced row echelon form, and you would have came out to x. X is going to equal 4. Y is 3. Z is 2. And W would have been 1. Does that sound correct? Okay. So make sure you're good at using your calculator. On Friday we have a senior assembly in the morning. So we have a shorter period in class, which means we're going to have a shorter test, which means I might just put more calculator on the test versus handwork. Okay? So you do have to know how to do everything by hand, but perchance ones that I was going to have you do by hand, I'll just have you use your calculator on. Okay? So that will be how I shorten the test, by letting you use your calculator on more. You can use your calculator on all the problems. However, I'll say do this by hand, check using your calculator, which means I need to see all your work by hand. If I don't see any work, I assume you did in your calculator and you don't get points for that particular problem. Any questions on that? So this week's going to go pretty quick. Monday, Tuesday, Wednesday lessons, Thursday review, Friday test. All right? And realistically, after today, we just have one more concept, and that is using inverse. So we have 2 days to talk about the inverse operation of a matrix. But today we're just going to talk about multiplication with matrices. And before we actually get into the multiplication, we have to learn the rules. So remember, with adding and subtracting, they had to be the exact same size. If I had a 2 by 2, the only thing I could add to it is another 2 by 2 matrix. Just like that, multiplying has its own set of rules. This time, however, they don't have to be the exact same size. But what they do have to have is the number of columns in our first matrix must equal the number of rows in the other matrix. All right, so your first matrix, you're going to count your columns. The second matrix, you're going to count the rows and make sure they're equal. I'm going to show you a trick to doing that really quickly so you're not having to write a whole bunch of stuff down. Same thing with this one. I'll show you a trick how to get the next one. It says that the product matrix will have the dimensions equal to the number of rows of the first matrix and the number of columns of our second matrix. The entries in each row are multiplied by the entries in each column, then they are added. All right, here's the trick to take care of those first two things. What you're going to do is anytime you have multiplication, anytime you see multiplication, you're going to write the sizes of your matrices underneath. All right, so this is a 2 row by 2 column, 2 rows by 2 columns, 2 by 2. This is a 2 rows by 1 column. So as soon as you write that, you have the first two taken care of, because all you're going to do is you're going to put an equal sign between these two. And you're going to check to make sure that these two numbers are equal. Because this is the column of the first one. This is the row of the other one. If these two numbers are equal, you can multiply. If these two numbers are not equal, then you cannot multiply. All right, likewise, this 2 by 1 that's left over is going to be the size of your resulting matrix. So just putting that box around those two numbers will A, check to see if you can even do the multiplication, and it's also going to give you the size of your solution matrix. All right, so just this simple act can take care of those first two things. Then what you need to do is you need to multiply each column or each row in our first one by the column of the second one. That's why we have A times P goes here plus B times Q, which goes here. If we had another column here, we'd put a space and do the exact same thing with the next column. Then all we do is we go down to our next row, which is CD, and do the exact same thing. So now it would be CD times PQ. So it would be C times P right there, D times Q, and we put a plus sign in the middle. It's pretty easy when you have a 2 by 2 times a 2 by 1. It gets a little more complicated when we start making it bigger and bigger and bigger. All right, let's go ahead and do these two examples, and then we're going to change one. All right, I have a matrix with rows 2, 5, 5, 3 times another matrix with row 1, and row 2 is 2. So the very first thing I'm going to do to not make any stupid mistakes is to say that this is a 2 by 2. I got 2 rows by 2 columns. The other one has 2 rows by 1 column. I'm going to make sure those middle 2 numbers are equal. I am good to multiply. I also know that my resulting matrix is going to be a 2 by 1. Alright, so this is going to equal. We're going to go straight across that 2 and 5, and we're going to multiply that by the 1 and 2. So you can think of that first one as making kind of a right angle. Alright, so we're going to have 2 times 1 plus 5 times 2. Then we're going to go to the next row, which is 5 and 3, and we're going to multiply it by that 1 and 2 as well. So a shortcut to this is if I have a 1 and 2 here, we should have a 1 and 2 down here. Alright, so as soon as you have these 1 and 2 set up, we can already know that, well, I'm going to have a 1 and 2 down here. I'm just going to do the exact same thing, but with a 5 and 3. So it's a 5 and a 3, an addition sign. Well, that's going to equal 10 plus 2, which is 12. And then we're going to have 5 plus 6, which is 11. And this is, in fact, a 2 by 1, and we said it should be a 2 by 1 because that's my remaining numbers that are left over after I put that box around it. Okay, let's shift over. I have a 1 row by 2 column matrix, and that negative 3, 4 has 2 rows, and it has 1 column. So we're just going to put an equal sign, make sure that 2 equals 2, we're good, so I can multiply. My resulting matrix should be a 1 by 1, which is just one element, 1 row, 1 column. Alright, so we are going to equal, well, I only have 1 row and 1 column, so it's going to be 2 times 3, or 2 times negative 3, I should say, plus that 3 times 4, which is going to equal negative 6 plus 12, which equals a positive 6. That is a 1 by 1, and we are done. I'm going to change up our next example really quick. So we have a 1, 2, 3, 4, negative 2, negative 5. This one is possible to do, but I want to switch it up so we have an example in our notes of something that's not going to work. So I'm going to scratch that out. I'm just going to reverse the order of them. So I'm going to have a negative 2, 5 first. And I'm going to multiply that by 1, 2, 3, 4. Now I want to note right here, multiplication is usually commutative. 2 times 3 equals 6, 3 times 2 equals 6. The same application of multiplication does not work for matrices. These are not commutative property. So this being multiplied by this is going to have a different answer than this multiplied by this. In fact, this is possible to multiply. This we'll see is impossible because that negative 2 and 5 are in a matrix that's a 2 by 1. Whereas the other one I'm multiplying by is a 2 by 2. And in my book, 1 does not equal 2, so we cannot multiply. Make sure you have this example down. Alright. I don't know how many times we have tests where I show you one that doesn't work, and how many of you try to make it work on a test. Alright, it doesn't take long to check it. You just put a box, does not equal, cannot multiply, versus some crazy work and you just put in there, I'm not sure how to do it. This is, I cannot do it. So make sure you have that down, maybe put a star by it so you remember. Okay, our next one we can multiply. This is a 2 by 2 times a 2 by 2. Okay, no, that's fine. I just didn't know if you have a question. Okay. That 2 equals the 2, so we're good. And my resulting thing should be a 2 by 2. This is going to be a little bit different because now we have a 2 by 2 times a 2 by 2. How this is going to work is we're going to start out with 1 and 3 and multiply it by that 2 and 6. So it makes that L shape. So we're going to have a 1 times 2 plus a 3 times 6. Now as soon as I shift over a column, I'm going to leave a blank here. Alright, so we're no longer adding. You only add if it's in the same. So it's 1 times 2, 3 times 6. We add those two things together. Now we're going to shift. Maybe I'll highlight in red. I'm going to stick with that 1 and 3, but I'm going to shift over to that 4 and 8. So this time we're going to have a 1 times 4 plus a 3 times 8. So I repeated the 1 and the 3, except with the other column. All right, then we're done with that row, and we go down to the 5 and 7. We start all over. So it would be 5 times 2 and 7 times 6. Well, if I'm ever going down, kind of a shortcut you can do is you can just throw your 2 and 6 down. All right, because we're repeating those columns, which means I can throw down this 4 and this 8. And this time I'm using 5 and 7 instead of 1 and 3. So anywhere we had a 1 and 3, we're just going to replace with 5 and 7, because we'd have 5 times 2, 7 times 6. Yeah, if I just put 5 and 7 here, I have 5 times 2 and 6 times 7. So we just replace this with 5 and 7. Our next one should be 5 times 4. Let me highlight that really quick. We're still on the 5 and 7. We shifted over to the 4 and 8, so it should be 5 times 4, 7 times 8. So if I replace this with the 5 and 7, yeah, I do have the 5 times 4 and the 7 times 8. All right, and this is just going to equal 20, 28, 52, and 76. That is not the best 2 of my life. Let's write a better 2. There we go. All right, questions on 2 by 2 times 2 by 2? And we can keep expanding this over and over and over. So the longer this gets, the longer this has to get, and the longer these are going to get. All right, so like I said, multiplying matrices is not commutative. So that means if I tell you to do A times B, and then I tell you to do B times A, it's possible that'll be the same answer, but more than likely it'll be 2 different answers. So don't just say, that's the same answer. All right? These 2 are going to be different depending on what order we do it in. So the first order we're going to do it is A times B, which would be matrix A, which is rows 1, 3, 5, 7, 8, 2, times B, which is going to have a row of 2, 4, negative 1, and the other row is 6, negative 3, 2. I'm going to note the size. My first one is a 3-row by 2 columns. My other one is a 2-column by 3 rows. I box in those middle ones. 2 equals 2. I can do the multiplication. And my resulting matrix is going to be a 3 by 3. So it's going to be bigger than our other ones. So we're going to end up with a 3 by 3. It's still going to be the same exact method. I'm going to take the rows and multiply them by the column. So my first row is 1, 3. My column is 2, 6. So my top left spot is going to be 1 times 2 plus the 3 times 6. Then we're going to shift over to that 4, negative 3. We're still in that 1, 3, so it's going to be 1 times 4 plus 3 times the negative 3. And then we go to the final column. Let's pick green. That's that negative 1, 2. And we still are using the 1 and the 3. So we are going to have 1 times negative 1 plus 3 times the 2. So like I said, the trick is, so it's not a trick. You can go through this and go, okay, maximum is 5 times 2, 7 times 6. 5 times 4, 7 times negative 3. 5 times negative 1, 7 times 2, and then repeat the thing on. But we're using the exact same numbers, so a little bit of a shortcut to speed things up is just shift down your 2, shift down your 6, and that's going to go to our bottom one as well. Because it needs to be a 3 by 3, so I'm going to create a 3 by 3. Same thing's going to happen with the 4 and the negative 3. You don't have to do these arrows. In fact, I won't on the next one. And this will kind of keep you from making mistakes along the way. As long as I did this first one right, these will travel down, these will travel down, these will travel down. Then we just look what numbers are multiplying. My next one is a 5 and 7. So rather than 1 and 3s, I'm just going to put 5 and 7s along the way. So we have 5 and 7, put a plus sign in between. 5 and 7, put a plus sign in between. 5 and 7, put a plus sign in between. And my bottom one is that 8 and that 2. So we're going to go 8, 2, 8, 2, 8, 2. So once again, you can go through the logic and go, okay, it's 8 times 2, 2 times 6, and just constantly do that. This way is just a little quicker, and you're less likely to make mistakes along the way. All right, I'm just going to double check. Yep, that's a 3 by 3 column, so then I'm going to do the math. And rather than doing it all in front of you, let's just have, this is going to be a 20, rows 20, negative 5, 5, 52, negative 1, 9, 28, 26, negative 4. And that is definitely a 3 by 3. All right, so like I said, not commutative. B times A is most likely going to be a different answer. We're going to see that almost immediately. So if I do B times A, we're going to put B first and A second. So we're going to have, oh, BA, didn't even notice that. We're going to have 2, 4, negative 1, 6, negative 3, 2, and we're multiplying that by a matrix with rows 1, 3, 5, 7, and 8, 2. Our first matrix is a 2 by 3, and we're multiplying that by a 3 by 2. Yep, I can do the multiplication because it's 3 equals 3. My resulting thing should be a 2 by 2. When I did A times B, I ended up with a 3 times 3. Just changing it up changes even my matrix size. So even that matrix size is going to be different depending on which direction I do my multiplication. All right, so we should end up with a 2 by 2. I'm going to let you do that 2 by 2 on your own. But you should end up with a 2 by 2 that's 14, 32, 7, and 1. And then when you get done, I want you to check using your calculator. We haven't done this yet, but you have all the skills. You're just going to edit 2 of your matrices. So you'll edit A and you'll edit B. Then rather than doing that RREF at the home screen, you're just going to go to your matrix column and hit A or B and multiplication sign, and then your matrix B. So I want you to go ahead and give that a shot. I'll be around to help. That one does not have those buttons on it.
Oh, yeah.
Did you use a calculator too? Yes. That worked? Did your calculator work too? So you're going to hit second in the matrix spot, and then you just go edit. And you're just going to have to come up with the size. What is this? What are you doing? You're doing A or B? Oh. No. We have to enter in each matrix. Each beginning matrix. Okay. There you go. Then we're going to make that second one. Just remember which one stands for which, right? So that's your 2 by 3, so that's really your B.
Oh,
Your A is really your B.
that's okay. That's okay.
That's okay, yeah. And we're just going to quit. Now we're going to hit our matrix button. Just do. Nope, go back. If you'd enter right now, A is going to pop up there. And then we're going to multiply it by B, right? Mm-hmm. And you hit enter, and it'll do all of it for you. You calculated yet? Yours work?
I don't think I got the right answer.
Okay. Let's see what we did.
Are you just doing
Okay.
that?
Let's go back to our matrices. So let's go back to A. Yeah, maybe we had a mistake in there. Yeah. Alright, so we'll do there.
Oh, it's -3.
Yep. 2. Yep. That's good. Alright, cool. So try it again. There you go. So on a test, what I would do is I would do everything. Multiply it out right on the answer, and then I would double check to make sure my beginning matrices were
Okay,
correct.
okay.
Okay, make sure you at least try it. You're going to be able to do it on your homework, but you have to do it by hand first. You can just use it to check your answers. All right, the very last thing we need to do is solving using this method. So this is another method of solving, but it really is kind of the same as an augmented matrix. So I'm doing 3, 2, 4, negative 1 times x over y equals 1 over negative 6. So we're doing matrix multiplication. So as soon as I see matrix multiplication, I'm going to make sure it's possible to do it. So I'm going to say this is a 2 by 2. I'm going to say this one is a 2 by 1. Make sure those two middle terms are equal. Yep. My result should be a 2 by 1. And yep, 2 by 1. So everything works out. Everything checks out. This should be possible to do. So we're going to go ahead and do that multiplication. So just remember we do rows, or first one times columns the other one. So we're going to have 3 times x plus 2 times y. And our bottom one's going to be that bottom row times the column, which would be 4 times x, plus a negative 1 times y. Well, this is supposed to equal 1 over negative 6. So we can just rewrite this in normal algebra form, where I'd have 3x plus 2y equals 1. And on the bottom I'd have 4x minus y equals negative 6. So now I could put it in an augmented matrix and solve it that way. I'm just going to solve it using elimination, because that's why we teach you substitution and elimination. Sometimes that's quicker than even plugging it in a calculator. So I'm going to create a 0 pair by multiplying the whole bottom one by 2. So that means I'm going to have 3x plus 2y equals 1. And we'll have 8x minus 2y equals negative 12. Elimination requires me to add both of the equations. 8x plus 3x equals 11x. This is a 0 pair. And we're going to have negative 11, so x just equals a negative 1. Now I need to get y by just plugging it into one of the equations. I'm going to plug it into the 3 times x, which I'll change for a negative 1, plus 2y equals 1. Well, 3 times negative 1 is negative 3. Add 3 to both sides. I'm going to have 2y equals 4, and I'm going to end up with y equals 2. So even though writing it out, elimination might seem long, most of this you can do in your head. All right, so a lot of times you can just use that to check answers. All right, any questions about anything we covered today? The big thing I want you to keep straight is that if you're adding or subtracting, your matrices have to be the exact same size. Multiplying, they don't have to be the exact same size, but the columns have to equal the rows. So do this check if you're multiplying, only multiplying. Adding and subtraction require them to be the exact same size, so you don't need to do this check. Multiplication is that. Keep it straight.